Hi guys, welcome to our first installment of talking through the building ontologies with BFO, and BFO is Basic Formal Ontology, going through the book. We're students of ontology from the University of Buffalo. We're going to go through each chapters, maybe multiple chapters at a time, discovering discussing what we discover in the book. And this is going to be done with me and my partner Ian, and we're going to present what we have and show you how ontology relates to your everyday. Ian?
Yeah. I would love to start by just introducing myself. My name is Ian. I'm a graduate student at the University of Buffalo, Master of Science in Applied Ontology program. And my background is from the library world. So I've worked in libraries for about 5 years. And yeah, that's my experience.
For me, I am a student of ontology from the University of Buffalo doing my graduate classes there. My background is in software development. So you can see just coming into this, we have different background, we see things in different light, but we're going to try and have ontology measures together. And this is what one of the great reasons why we have ontology, because we all speak different languages, and ontology is supposed to be that master dictionary that helps us all become in sync.
Mhm.
So,
Beautiful. I'll also say really quick before we get going, just that a lot of this content is going to be coming out of the book, which is
building
uh,
ontologies with
sorry, yeah, building.
ontology.
Yes, yeah, by Robert Arp, Barry Smith, and Andrew D. Spear, and it's available on the MIT Press, and we'll put a link to that book in the notes underneath the show.
All right.
Cool.
So,
All right, so should we start with?
yes. I'm going to welcome everyone. Welcome if you found this channel because you're inquisitive about ontology. You're in the right place. If you are looking for BFO, we're going to help you understand the book. We'll do our best as we go, and from our knowledge as students, we'll be able to like go through each chapter, trying to explain and have this a little engaging. So I'm going to welcome everybody. This will be the first of a series that we're going to be having. We're going to examine and explain the top level ontology for basic formal ontology. You will hear us refer to this as BFO a lot. Don't be scared. It's basic formal ontology. We will refine, we'll explore like how this is realistic, common sense examples that we will have. And as we go, you will discover this. Ian?
Yeah. Um, well, I would love to start out by just asking what is an ontology?
An ontology for me, I would say, is the blueprint. So you want to build a house, you want to build a hospital. We all have blueprints for this. It's something you can show a construction crew, and they will understand what you're trying to build. Ontology is supposed to be that building force that helps everybody across different disciplines understand at a goal instead of talking past each other, be on the same understanding.
Great. Yeah, I think I would add to that. I'll actually read the definition out of the book here, that it's a representational artifact comprising a taxonomy as proper part, whose representations are intended to designate some combination of universals, defined classes, and certain relations between them. Now, that is a lot. But like Obi said, it's a representational artifact. So it's something that can help people translate between two, to increase interoperability between systems. So, for example, if I have a map and it has a legend, and I have a map and it has another legend, those two maps aren't necessarily going to be talking to each other. If I have two maps and they have the same legend, then we can start making inferences between the two maps. So, it's an artifact that's going to represent things, and it has a taxonomy as its basic backbone. We'll talk more about taxonomies later. And then there are also three things that we're going to be discussing, like talking about mostly, which is universals, defined classes, and then the relationships between them. And so we'll be talking about that as well.
I just want to add one thing is that you don't know, but you use ontology every day. Our vocabulary is actually an ontology. Is if I say something like, I drive a BMW, I didn't say what I said, I drive a BMW, that was it. Your mind went straight to he drives a car, is it an SUV, is it a sedan? You knew what I was talking about. So this is why ontology is very useful.
So when we're talking about ontology,
Okay?
What kinds of terminology are we looking for?
So I think when you start talking about ontology, I will bring this according to how it was referenced. Is I'll kind of bring it. Let me bring it home to where everybody will understand. I just talked about the BMW example, but I'll bring it more into a very relational one for everybody, which is like music. We all listen to every kind of music. Some people listen to rap music, R&B, blues, um, but meta, you come to the realization that every music has a structure, right? It has its own scale, chord, it has its own harmony, and this kind of build a consistency. If I go to like a heavy metal show, there's an expectation of what chord or harmony I'll be expecting versus going to an R&B. And this is where ontology helps you translate those in reality. Because now, if I'm going to a Celine Dion show, I know my tempo and ontology that I will be expecting is going to be the tempo is going to be lower than if I go to a heavy metal show. I know what I'm expecting is more on the high side. So it helps us like create expectations, make us understand what already exists, and that can linger into translation to other things.
Cool. Yeah, thanks, Obi.
Yeah.
I would also, I heard you mention something about reality in there, that we are modeling reality when we're modeling an ontology. That BFO specifically is a realist-based ontology. So we want to be careful about the difference between use and mention also, is something that's mentioned in the book a bunch. That if we are modeling something, we want to model what the data is talking about. So not what the data says, but what the data is actually talking about. We're not talking about the thing that the data is mentioned, or we're not talking about the way that the data talks about it. We're talking about something in the world um, that is being represented.
That is true. And I think another part of that I'm going to stress about is that under stress, when your ontology is under stress, it doesn't just give up. Because when you have a good ontology, as you increase the complexity, it stands the test of time. So you keep doing it, you keep increasing the music, you can create a new genre of music like Afrobeat, and you will still use the same chords that you use in music regularly. It's just played in a different way, right? The music doesn't, the chords doesn't change. It's just the rhythm now has changed, and ontology brings that back to life because now, if I wanted to learn how to play a different genre, I could just take the mapping of the scales and say, okay, this is what I need to play. Instead of playing my tune faster, I would adjust the expectation because of the ontology is giving me that information in influx. Another thing I
Um,
will add to that would be, I think from when you get that, you kind of see, since we're using the music example right now, you come, like I said, Afrobeat, and I've said blues, and I've said um, jazz, and I've given a different variety of music. Now is where the taxonomy comes into play. And I know Ian talked about taxonomy earlier. I will let him take it from here to kind of to unwrap the taxonomy word for us.
a taxonomy is a way of representing things in a hierarchical way, specifically in is a relationship. So if we're talking about something, it's going to be this is a this is a this. I will throw an image up here. And so, for example, a human is a mammal, and a mammal is an animal. And so it's representing all of the categories that you're talking about within that specific structure. Those are the only relationships that we're going to be talking about when we're talking about a taxonomy. This thing is a this thing is a this thing. The way the BFO talks about things is everything is an entity. That's the very top level. And then it breaks down into continuance and occurrence. A continuant is something that's going to continue. It exists through time. An occurrent is something that occurs, it happens, it's a process, but it doesn't necessarily continue like we'd be talking about a rock or a human as a continuant. It might be I'm shaving or I'm going for a run. This is something that would be an occurrent in BFO. And then everything else comes off of that. So is it a continuant? Is it an occurrent? And we're always going to be asking those questions as we start to make more and more different levels of the taxonomy that we're talking about. And that helps us have a really clear definition of what the thing is, because we can go all the way up to the top and we can say this thing at the very top, it's an occurrent, for example. So that's helpful for defining things uh, within our ontology.
I love this. This what Ian just summarized for us has made me. It's one of the things why I love ontology. Right? You have the taxonomy, which is the hierarchy that he just explained using biology. We are not inventing species, right? We're just discovering and classifying them, which is what he did and said he will put the image up, which is great because that now tells me there a little thing section that I want to like kind of make you understand is the controlled vocabulary, which is just a list of terms, like what he says, the continuum. These are list of terms. We want to do like the taxonomy, which is the hierarchy, which we use the biology example, the terrestrials, which is like all the synonyms and loose relations that we have for a meaning of something. And lastly, we'll then get into ontology, which now has the formal definition and logic constraint. He gave an example of him shaving. I wouldn't expect a cat to shave, so I will have that logic constraint. Is a cat can shave itself? I will have that logic constraint in my ontology, even though in biology some mammals can shave. So that logic comes into it. So these are like the we are relating what you're saying to the exact word, and then the logic proves it, which is the beauty of ontology. And I've now just love it because it's consistent, it checks and it's consistent checking and inference. That way that the model catch contradictions before the production catches it. And it helps us like understand what is going on and be able to like improve our processes. I think another thing I would want to talk about is you mentioned the upper level and the supporting domain, right? One of the beautiful things I love about ontology is the upper level is just a skeleton. You can start like having like other levels attached to just one, like an upper level, right? You have the skeleton on top, and then you can have more structured, defined very close to what you want defined under that structure. And I think that becomes very big when you start going through the niche. But having that loose upper ontology means you can extend it, and somebody can extend your ontology and use it for a very simple process.
Yeah. I'll also add to that BFO specifically is built on a hub and spoke model, which means that the ontologies themselves are interoperable. There is a problem that can happen where you might build an ontology, but now you have a bunch of siloed ontologies because they don't speak to each other. So you think you've solved this problem within your data, but if the ontologies aren't able to speak to each other, it won't make sense actually. Like you won't be able to work across domains. And so what BFO does as a top level ontology is increases interoperability amongst different domain ontologies as well.
That is one of the benefit, another benefit of BFO. It's like it's domain neutral, right? It it doesn't tell you what a glasses is specifically, but it can tell you what kind of glasses on a high level, right? It can do that. It can also part of this is where we do that big split, what you were referring to, the continuance and the occurrence earlier. And those are the core decisions in BFO, right? Things versus happening. Think I would thinking about it like something or is it happening? So like continuant is something that persists through time, right? Like a chair. A chair is a chair. A cell is a cell. Your beard is your beard. An occurrence is something that unfold over time, like a concert. I went to a concert yesterday. I'm going to go to a concert next week. I have a surgery in 6 months. These are things that happen, unfold over time. And I think when you start understanding this concept, it will help you be a better ontologist. Yeah.
Yeah, thanks, Obi.
Okay. I would say I will emphasize formally on like definitions like inherit in, um, participate in, part of, located in, like because when you start having those definitions, this is one of the other things why GraphDB is awesome, is that it inherits from, which is like you inherit from something. I inherit my features from my parents, and you inherited something from your parents. Um, I participate in sports, and I'm part of the ontology class located in Buffalo. And you see how ontology is beautiful because now I'm looking at this formal definition and I can relate it to myself and I can relate it to like being connected to a lot of things. But we don't see that every day anymore. We think connection is just to Instagram or connecting me to my shopping cart. But in reality, we are connected more than we think.
Yeah, beautiful. Anything else from chapter 1 and 2?
I think the parting thing I would say is from what I got from 1 and 2 is like ontology is about reality, not just data labeling, but about the reality of what is going on. We have the universal and the particular in the foundational. We have like the continuant versus the occurrence in the non-negotiable. Dependencies matter, like quantity, role, like functions, entities, right? That dependencies matter because we need to know where we're going. We have the upper ontology like BFO that enforces structural discipline, so that way when we scale, we don't buckle down and break under pressure, right? And we have the logic rigor that provides and reduce ambiguity, so that way if we're to do this right, we'll have less hallucination when we visit wherever we're using it for, or we're using it for construct a language. People don't get ambiguity about it. If I say DNA, all the people in the hospital know. If I say he got an inject, if I say he has a headache, everybody in the medical field knows what you're talking about. Regular people knows what you're talking about. So that logic provides, and like remove the ambiguity helps a lot, because when you remove the ambiguity from the problem, you actually have a logical response back to get the best possible answer.
Well, I think this is a good place to end, and
Yes.
please come back and join us for chapter 3. We'll be talking about in our next episode in this series.
All right. Thanks, guys.
Yeah, till next time.
All right. See you next time.